like, oh, what the heck is going on with this? Okay, so let's go ahead and start with number 7. First thing I want to do is figure out what side the variable is on. Okay, because I want to isolate it. I want to get it by itself on one side of the equal sign, just like I said here. So to do that, I visually put a line in. So I can visually see that this part of the problem is the left side, this part of the problem is the right side. And I now know that my variable is on the left side of the equal sign, which means I'm going to ignore -5. I want to work on this. Okay? Which means to get the x all by itself, I have to make the -3 disappear, and I have to make this 2 disappear. So before we do that, we got to figure out what are these guys doing. So I know that the -3, when it's written like this next to a variable, this is actually multiplication. So I'm going to put a little multiplication sign. This 2 here, because there's a subtraction sign in front of it, I know it's subtracting. Okay, so we have multiplication of -3, and we're also subtracting 2. So when we solve for x, or get x by itself, or isolate x, we have to do and get rid of -3 and 2. But it's very important that you know the order to get rid of these things, to make these guys disappear. And here's the rule, okay? 99% of the time when you have equations, the first guy you want to make disappear is the guy that's adding or subtracting. So if we look at our example here, the guy that we want to make disappear first is going to be 2, because he's the guy that's adding or subtracting. So how do we get rid of something that's subtracting? We do addition to both sides. So again, the rule is, let's get rid of the adding or subtracting first. So I'm going to do +2 or add 2 to both sides of the equal sign. This cancels out. We're left with -3 times x equal to -3. Okay? And then after we're done with the adding and subtracting, the next thing you want to do, the second thing you want to make disappear, is anything that's multiplying or dividing. So if you look, we have -3 multiplying. So to get rid of multiplication, we do division.
Do we have to do that part, or can we just leave it as 3x?
Remember, the goal is to get the x by itself. So if you don't do that part, it would be incorrect.
Or I mean, can we just leave, we can't leave it at -3?
You mean the little multiplication symbol?
Never mind.
No, don't never mind me. Explain. So I don't want no confusion here. So what's your question?
No, it wasn't a question. I mean, it was just because in my math class last year, we were just able to leave it at 3.
So you would leave just like this step here?
Yeah.
Yeah, you don't want to do...
And that would count as the answer.
No, you want to... What you really want to do is get the x all lonely by himself.
Okay.
Okay? All right. So we divided by -3 to both sides. This -3 is gone, and here's what we want. We want the x by itself equal to 1. And our answer should always be in this format, okay? The x might be on the right side sometimes, which is okay, but we just want x by itself, or the variable by itself, and then equal to some type of number. All right, let's jump over to 18. Again, let's split the equation. So here's the left side, here's the right side. My variable is now on the right side. And now we have to figure out what these numbers are doing, because we want to make them disappear. So let's look at this one, because this one's kind of easy to see. The 3n, or the -3n, this is actually multiplying because it's next to the n. Okay? This guy over here, this 3, a lot of students will make the mistake and say, oh, this 3 is subtracting because it has this negative here. This negative sign actually is for this 3. So this negative sign has nothing to do with this 3. The sign for this 3 is the sign in front, which is not written, but we're going to write it in. When there's no sign in front of a number, it's always positive. Okay? So to sum this up, this negative 3 is multiplying. This 3 is actually adding. I know it looks weird, but that's just how it works. Okay? So now we got to do, what should we get rid of first? 99% of the time, we want to get rid of the guy that's adding or subtracting. So we already know this guy's multiplying, so this is the guy that's adding or subtracting. So since he's adding, we're going to subtract 3 to both sides. So 15 equals negative 3 times n. Okay? So again, our goal is to get the variable all by itself, but if you notice, the n is still connected with something. We need to get rid of this negative 3, and we know it's multiplying, so the opposite of multiplication is division, and we do that to both sides. That cancels, and let's do the work over here. 15 divided by negative 3, that's negative 5, equals, and then we're left with n. And n's by itself, so we're done. Okay, let's jump over to 9. And 9's a little different because this is the 1% problem, where we break this rule over here that I talked about. Okay, so let's look at number 9. So let's start it off exactly the same way. Split it. My variable's on the right side. So let's check out what's happening. So we're subtracting 3, and then we're also dividing 2. So we got to get rid of subtraction of 3 and a division of 2. So if we follow this rule, the first thing we should do is get rid of the subtraction of 3 by adding 3 to both sides. But here's the exception. You can never get rid of addition or subtraction if there is something dividing the addition or subtraction. If you notice, this 2 is dividing the subtraction of 3. So we cannot touch this subtraction of 3 until we get rid of the division first. So that's the exception to the rule. If something is dividing your addition subtraction, you got to do step 2 first before we can do step 1. Okay? So this is what it looks like. I now have to get rid of the 2 first. And since it's dividing, to get rid of division, we multiply to both sides. 2's cancel out here. And this turns into negative 4 equal to r minus 3. Now, r is not by itself. We want to get rid of the subtraction of 3. The opposite of subtraction is addition, and we're left with negative 1 equals r, and now we are done. Okay, so these type of problems are the exception. If your addition or subtraction number is being divided, you cannot get rid of it first. You have to get rid of the dividing number first. All right, let's jump over to number 10. And let's look. B is on the right side, so we got to get rid of this 3 and this 3. We know that this 3 is multiplying, and this 3, before we say it's subtracting, we look at the sign in front of it, which is nothing, but we know it's positive or adding. So we have addition of 3. Since there's nothing dividing the addition of 3, we want to get rid of the addition first. So we go back to our normal rule here. So we're going to subtract 3 to get rid of an addition of 3. What you do to one side, you do to the other. This is negative 9 equals negative 3 times b. And then to get rid of something that's multiplying, we divide. We get here positive 3 equals to b. Doesn't that just give you chills? It's amazing, right? It's so amazing. We're going to do 4 more. Just kidding. You're going to do 4 more. All right. So notice I put it here. You're going to add these problems to Friday's upload. Okay? I even put the assignment you're going to add these to. So when you upload, you should have 28 problems in that upload. Okay? So I'm going to sit this there for like a minute. So if you need to take a picture of it because you were just watching, or if you need to copy the last bit of it down, I'll give you 1 minute and then I'm going to give you the next set of problems. As we do these problems, remember it's very important that you understand this concept, that our goal is to get the variable all by itself. Okay? So as I go through these, try to, if you're struggling, try to do them as I do them. Okay? Especially if you're struggling. If you know how to do these and you're getting them right all the time, then do it your way. But if you're struggling, put this line in. Ask the questions I'm asking of you, okay? So I put the line in and then ask myself, the question I need to answer is the variable on the left or the right, okay? So we see the variables on the left. Now the next thing I want to notice is I want to get this variable, this letter, all by itself. Okay, so I need the 1 to go away, I need the 2 to go away. In order to do that, we got to figure out what the 1 and 2 are doing. Are they adding, subtracting, multiplying, or dividing? So we look at the 1. The 1 is adding, okay? This 2 is dividing. So we go back to our rule here. If you have 2 or more numbers that you need to make disappear, you always want to make the adding or subtracting disappear first. Okay, that's usually how the rule works. Okay, there's an exception that we talked about already. So if you look, I want to make the addition disappear first. Okay, as long as this addition, this number, is not being divided by a number. So if you look, addition of 1 is not being divided. So I want to get rid of the addition of 1 first by subtracting 1, and what you do to one side of the equal sign, you do to the other. So this cancels. We do this math. 1 minus 1 is 0. Equal sign. I'm just basically copying whatever I have left. N minus 2. Now, the n's still not by itself because we have this 2. Now we ask ourselves the question, what is the 2 doing? The 2 is dividing. What's the opposite of division? Multiplication. So we have to multiply this number to both sides. What you do to one side, do to the other. These 2's disappear. They cancel each other out. And we're left with n equal to 0 times 2, which is 0. Okay, let's move on to 12. Number 12. Okay, put our line in. And then ask ourselves, is our variable on the left, on the right? It's on the left, it's a k. And now the next question is, what do I have to make disappear so the k is by itself? I have to get rid of this 2 and this 2. This 2 is subtracting, this 2 is dividing. So the rule says we want to get rid of anything that's adding or subtracting first, okay? But here's the problem. The exception of the rule is we cannot get rid of adding or subtracting first if it's being divided. So if you notice, this adding or this subtraction of 2 is being divided. So we cannot touch this subtraction of 2 until we get rid of this bottom 2. All right, notice the difference between these two problems here. This one we were able to get rid of the addition. Over here we can't get rid of the subtraction because we have a division of 2. So we have to get rid of division first in this problem. And what gets rid of division? The opposite of division? Multiplication. What you do to one side, do to the other. The multiplication and division cancel out over there. Rewrite what you have left. We have k minus 2 equal to negative 4 times 2 is negative 8. Okay? And then look, k is still not by itself. We still have the subtraction of 2, so this needs to go away. What gets rid of subtraction? Addition. So we're going to add 2. What you do to one side, do to the other. K equals, and we just simply do this math. Negative 8 and positive 2, that's negative 6. Let's jump over to 13. Put our line in. Our variables on the right side. So that means we got to get rid of this 1 and this 3. We know the 3 is multiplying because it's written right next to the variable. So I'm going to put a little multiplication symbol there. And then this 1, we look at the sign in front of it, which is subtraction. So this 1 is subtracting. So the rule says get rid of addition or subtraction first. So this 1 we're going to get rid of because there is no division under it. So we can actually do addition and subtraction first. So let's do the opposite of subtraction, which is addition. Okay, what you do to one side, do to the other. We get 18 equal to negative 3 times a. And now a is almost by itself. We've got to get rid of this negative 3. So we know it's multiplying. The opposite of multiplication is division. So we're going to divide by negative 3. What you do to one side, do to the other. The negative 3's cancel out over here. And we're left with 18 divided by negative 3 is 6 equal to a. All right, and that's done there. A is by itself. Last one here. So there's my line and my variables on the right side. And this is what you notice is slightly different. We actually have 2 of them. When this happens and you have 2 variables that are exactly the same letter on the same side of the equal sign, before you do anything, you want to CLT. And if you forgot what this means, it means combine like terms. That means I want to take this 8K, and keep in mind this 8 is positive, and I'm going to put it together or combine it with this negative 7K. And the reason I can do that is because they share the same variable. So I just got to do the math. Positive 8 and negative 7, when I put them together, it leaves me with 1K or just K. Okay, it's really 1K, but we can just call it K in math. Bring down the negative 8 we have there. Equal sign, negative 3. And now we ask ourselves, is K by itself? No. We have a subtraction of 8. To get rid of subtraction of 8, we do addition of 8 to both sides. Cancels. This is 5 equal to K. Okay. All right, guys. That is it. Make sure you get these problems turned in to the correct spot. I've said where to turn it in enough times. Hopefully you were paying attention. I'm now going to give you the access code, the check-in code. Please do not leave Zoom until you check in. I have a lot of students that are in Zoom and then they forget to check in. They leave and they're like, I'll check in later. And then I take roll right after this class. So if you're not checked in, you're absent. All right, so here's the check-in code. Boom.